Hi, this is Homework Helper video for the review for the third quarter final. This is Station 6 worksheet, Periodic Trends and Table S. So on this particular worksheet, I'm just going to have you go through Table S. Is this table that has a lot of information on it. And you're going to look at the trends. So we're going to be looking at sodium, which is Na, and that is atomic number 11. We're looking at chlorine, atomic number 17, cesium, Cs, atomic number 55, and lead, which is Pb, and lead is atomic number 82. Okay, so I'm going to start by just filling in some of the information from Table S. So sodium, the symbol is Na. I'm going to look up the electronegativity. The electronegativity for sodium is 0.9. The ionization energy is 496 kilojoules per mole, and the atomic radius is 160 picometers. If I go over to chlorine, the electronegativity is 3.2. The ionization energy is 1,251 kilojoules per mole, and the atomic radius is an even 100 picometers. So as I go across a period, actually I will do that at the end. Let's do cesium, which is number 55. Cesium has an electronegativity of 0.8. Cs is the symbol. Ionization energy of 376, and an atomic radius of 238 picometers. If I look at lead, which is Pb, number 82, the electronegativity is 1.8. Ionization energy is 716 kilojoules per mole, and the atomic radius is 145. So I'm going to be looking at these. So if I go across a period, what happens to electronegativity? It went from 0.9 to 3.2. So across a period, electronegativity went up. Let's look at ionization energy. 496 to 1251. Ionization energy goes up. Atomic radius goes from 160 to 100. Atomic radius goes down. Now if we go down a group, if I look at electronegativity, looking from here to here, 0.9 to 0.8, it goes down. Ionization energy, 496 to 376, it goes down. Atomic radius, 160 to 238, it goes up. All right, so now I'm going to use that information. I could have done across here also, and I could have done down here also. So as you go across the period, the electronegativity increases. Remember, fluorine is my most electronegative, and that's going to be located up here in the corner. So that's going to be fluorine. It's the most electronegative, so that makes sense. As I go down a group away from fluorine, I would expect the ionization energy to decrease. That's because the ionization energy is the energy to remove an electron, and that would decrease as your energy levels get bigger. So as I go across a period, for ionization energy, it increases. Going down a group, it decreases. So you see how if you just look up a couple of key elements, you can do all the work by looking at the numbers specifically. Atomic radius, as we go across a period, decreases. And as you go down a group, it increases because you're adding more energy levels. So these are basically the trends on the periodic table. If you look at the back side of this ditto, we're looking at atoms and their ions. So we're comparing, like, say, lithium 0 to lithium +1, or we're comparing fluorine 0 to fluorine -1. Okay, so atoms like chlorine are nonmetals, and they will gain electrons and they form negative ions. So how can I figure that out by looking at the periodic table? If I look at chlorine, located in the upper right-hand corner, these are your non-metals. The rest of these are all metals. It will gain electrons because chlorine has 7 valence electrons, so it only wants to gain one more to fill the octet. It forms a negative ion. I can see that here. The top ion here is negative when it gains an electron. And the ion, if I look at the negative electron, is going to be larger than the atom. If I gain an electron, then the ion is larger than the atom. So the ion is larger than the atom. And these are for the non-metal chlorine, non-metal anions. Atoms like potassium, if I look at potassium, potassium is located on the left-hand side, so that's a metal. And that will lose electrons. Remember, potassium has only 1 valence electron. It wants to lose that electron. The electron configuration is 2881. So if I lose this electron, I have an octet in the next energy level. I form positive ions. I can look that up. Potassium has the only oxidation number would be +1, so it forms positive ions. And the ions are smaller than the atom, because if you lose electrons, your ion will be smaller than the atom. So let's define the following terms. Ionization energy is the energy required to remove a valence electron. Sometimes they say the most loosely held electron, and that would be out in the valence shell. The electronegativity is the attraction for electrons. These two are related. If one goes up, the other goes up. If one goes down, the other goes down. Atomic radius is the size of an atom. We measure this in picometers off of table S. Okay, so that shows us the size. So this is a little brief review of periodic table. That should be helpful in studying for your third quarter final. I hope this was helpful.